In part 5, we learned about how to allocate memory using pointers and a library function called malloc. And that's great if all you need to do is grab a certain amount of memory and work with just that. But what if you need to make the array larger or smaller? How do you reallocate memory to do that? Well, you're going to do that with a function called realloc. And that's what I'm going to cover this week. I'm going to cover some advanced programming topics, starting with realloc, and then just kind of showing some of the things you can do with realloc. So let's start by writing a simple demonstration program. See what we can do with realloc. So I'm going to do a program here called, we'll just call it realloc. Now remember, to start your program, you need to do include standard IO because we're going to be printing to the screen, and include standard lib because that's where we get malloc and also realloc. I'm going to just do a simple program here. Well, there's my int for the main function. I'm not going to read anything with the command line, so I'll just do an empty argument list. Now I need a place to store my array, and so I'm going to make an integer array here. Int star will make that into a pointer to an array, and I'll just call this array. How big is that array going to be? Well, we'll do an integer variable called size. We'll just initialize that at 100. Now when you reallocate an array, when you do realloc, you're going to need to store that somewhere. And so just to get ready for that, let's create a pointer to a new array. And we'll do another variable called new size. We don't need to assign anything to it yet. And then I'm gonna loop through the array. So I'm going to create an incrementer variable. Let's go ahead and allocate the array. So remember how we used malloc. Malloc is going to return a pointer to memory. So I need to store that pointer somewhere. But remember, malloc is going to return the pointer as a void star because void indicates it's not any particular data type. You can cast it to whatever variable type you need. In this case, that means we need to cast it. So we're going to do this inside these parentheses, and we're going to cast that to an integer pointer. And then remember how we use malloc? Well, malloc is just going to tell it how much memory to reserve, and it needs to know that by doing some very simple math, which is how many elements do we need to have in there. We're going to have size, and then times the size of each thing. And in this case, the size of each thing is an int. And so remember, this together, that math is going to be how big your array is going to be. It's how many things are in that array, and times the size of whatever each thing is in the array. And remember, it's going to return a pointer to memory if that succeeded, but if it didn't succeed, it's going to return a pointer to null. So we need to test if array has been given the value of null. And if it did, we're going to go ahead and just print an error message. So we'll do fprintf to standard error and just say could not allocate memory with malloc. And then we'll go ahead and return back to DOS because I can't do anything anymore. Now let's go ahead and store some data. All I'm going to do is just store some data in so we know that there's data there. So I'm going to do, before I do that, probably should also just print a message. So we'll do a printf that just says the array is now, how big is it? Is that size long? There. All right, now let's go ahead and store some data. So we need to do a loop across my entire data. And there's different ways to do loops, but we're going to do a for loop. And what goes inside my for loop, it's going to be starting I at 0. And it's going to continue the loop as long as I is less than size. And then every time it does the loop, it's going to do I equals I plus 1. So remember, arrays always start at 0, and that's why we're starting I at 0. Let's go ahead and store a value. Array I is, we could just do as I, but let's actually make it a little more interesting. Let's actually just say I equals I plus 100. And that way we'll see there's actually something there, and it's not just a number. And now that I've stored something in there, let's go ahead and print it out. Printf, we'll do a number and then a space. And then what is the number I want to put in there? It's the array element I. I could do it as a separate loop where I store it once and then print it out after that, but we've stored it with this instruction, and now we're going to print it out with that instruction. That'll save me another loop. And then once I'm done printing it all that out, I probably should make sure I put a new line character at the end, because I'm not printing new line characters as part of my printf. And then let's go ahead and stop there for a second. Let's just free the array and then return back to the operating system. So I'm going to stop there for just a second, and we're going to save and quit. I16 GCC. We're going to just compile this to remind ourselves that it works. So we're going to turn on all warnings. We're going to output this as realloc.exe, and we're going to compile the realloc.c file. If I didn't make any errors. Now I'm not using the new size or the new array variables yet, and that's okay. So I'll take those warnings, but I can go ahead and run realloc. And so here it's created an array that's 100 elements long, and it's just stored values going from 100 to 199, and then printed those out as it goes. So let's go ahead and now modify that so that after we've allocated the array and done some stuff with it, let's go ahead and make the array bigger. So make the array bigger. I'm going to, how big is it going to be? Well, let's go ahead and first figure that out. So new size, remember I have that variable. It's going to be the size plus, let's do 50. And then I'm going to do realloc. So realloc is going to return a pointer to memory. Realloc will specifically allocate memory, and then if it worked, it's going to copy all the data from the old array to the new array, and then return the pointer to that new array. So I need to hang on to that. We'll call that that was new array, and realloc is very similar to malloc. Except in malloc, remember we did new size. How big or how many things do we want to store in there times the size of the things that are in there. Realloc is slightly different in that we also need to give it the array that it's working with. So in this case, it's array. And it's going to return a pointer to memory that's going to be a void star. So I need to do a variable cast here to int star. And that's how I use realloc. So I'm storing it into this new array. And there's my call to realloc of this array and now of this new size. Now, why did I store it into new array instead of just doing it over array? Well, I want to make sure that it succeeded or not. And if it didn't succeed, it's going to return a null value. So I should check that. If new array is null, then let's go ahead and print a message. fprintf to standard error fprintf to standard error could not reallocate memory with realloc. But the important thing here is the old pointer is still okay. All it means is that if it failed, it just wasn't able to allocate more memory, and it wasn't able to copy the old data. But the old pointer is still okay, and so that's good to know. So I don't need to actually return from and abort at this point. I'm just going to let myself know that that happened. Now, if it worked, I should do an else, and so that means that if new array is actually pointed to memory, I need to now hang on to that. So I'm going to just assign my array pointer to that new array pointer. And the size is now whatever new size was. And now at the end of this if-else block, array is the correct size of my array, and size is the correct number of elements in that array. So that's what we need. So I can print out a message here that just says printf the array is now that many size, and it's size. So that is how I've now reallocated my array. Let's go ahead and store some data in it. Rather than retyping the whole thing, let's go ahead and highlight this, copy, and paste. And then just so I know I've stored different data in it, rather than doing +100, we'll just do +1000. And so that's going to store data and then immediately print it back. And oops, I need to have my putchar for a new line. And now once I've done that, I can now free the array and return back to the operating system. So let's go ahead and try that and make sure that it worked. So i16 GCC, turn on all warnings and save it as realloc.exe, and we're going to compile the realloc.c. If it didn't make any errors, so now I can run that program, realloc, and you can see that at the beginning it's made an array of 100 elements long, and that has stored data from 100 to 199. And then it was able to reallocate the array. Instead of being 100 long, it's now 150, and it was able to store the values of 1000 to 1149. So that's how you use realloc to allocate more memory for an array. The important thing is that it allocates new memory and copies over the data and returns a pointer to that new memory. So once you do a realloc, you really need to stop using the old pointer. So I just reassigned the pointer. Now, once you're able to change the size of an array, that becomes a really handy thing. And an obvious way to use that is when you're reading user input. So as the old saying goes, if you create a string that's big enough for someone to type foo, eventually someone's going to try and type supercalifragilisticexpialidocious. So how do you prevent your string that you allocated to only be like 3 or 4 characters wide? How you actually prevent it from being overloaded? Well, you could do a check using that fgetS, but you can also write a function that reads data from the user, and as that variable gets full, it just makes the variable bigger. So it just makes the string bigger. And so let's write a version of that. This is going to require some pointer assignment that might be a little confusing, but follow with me on this one. So I'm going to do a new file called, we'll just call it longstr for long string. Now I'm going to do include standard.io.h and include standard lib.h, because that's what I'm going to do malloc and realloc. I need to have a constant that I'm going to define. So I'm going to define it as a constant way up here at the top, define, and then get longstr size increment. I can make this however big I want. Whatever seems reasonable for reading in a string to start with. Maybe 100 is reasonable at this point. You can make that larger or smaller as whatever seems reasonable for your program. Now let's go ahead and write a function. So I'm going to write a function. It's an integer function. It's going to return the number of characters that it read. And we're going to call this function getLongStir. And normally I would read a character string like that. But I actually want to be able to pass some data back and forth. So I'm actually going to do, rather than the pointer itself, I'm going to do a pointer to that string. And then rather than doing just passing in int string size, again, I want to be able to pass back values. I want to modify that string size value. So I actually will do pointer that way. And then I want to read from some file, and I could actually read from standard input, and in fact that's what I'm going to do here for this demo, but I also could read from a file, so we'll just go ahead and do that. We'll do read from file input. So this is going to be a longer function. Bear with me on this one. So we're going to do start by defining a string variable, and at the same time we should probably create a new string, because we know if we do realloc, we need to hold on to that temporary value somewhere. How big is this string? Well, we're going to say it's an int of stir size, and then int of whatever the new size is. I said I'm going to be returning as the value of this function the number of characters that it read, so we need to hang on to that somewhere. Let's say nchars, and I'll initialize that to 0. And then I'm going to be reading characters one at a time. So I could do a char ch, but I'm actually going to be using the fgetc, which, if you remember, returns technically an int. So I could pass this function a string that's already been allocated. In which case I would give it the string, and I would tell it how big it is, but it might not have been allocated. It actually might be set to null, which indicates it's not been allocated, or the string size that I pass it could indicate 0. So I should check that first. So let's check, let's do a comment here, check if we need to allocate the string. So I'm going to do an if statement here. Inside that if, I want to check for two different things. So I'm going to do if the string is null, or if the string size was 0. Then I need to allocate the string. So I'm going to do just real quick some sort of just a debugging statement. Remind myself that I'm about to do a malloc, and that way if my test program bombs somewhere, at least I know where it was. So this is a debugging statement. I can remove that later. So let's go ahead and now make the string size be the getLongStir size increment. And now I'm going to use malloc. And so I'm going to store that in stir. And if you remember, malloc's going to return void star, so I need this to be char star. There's my malloc. And then how big do I need this to be? Well, remember, it's going to be the size, the number of each thing, so it's going to be stir size, times the size of each thing in the array. So it's going to be size of a character. Did that malloc work? Probably should test that real quick. So if stir equals null, then I have an error. What am I going to return? Let's return like a negative number. Let's return -1. And so that's my my if statement. Now if my string that got passed to me was already allocated, then I need to do an else statement. And in that case, I'm just going to hang on to it locally. So I can just use one set of names, and I'll do that one as, so stir size is going to be whatever string size is passed to me. And stir is now string. So I'm just going to hang on to those variables locally. So now whatever happens at the end of this if-else block, stir size is how big the string is, and stir is now pointing to the string. Let's go ahead and now we're going to read from the input until we reach either the user's hit return, so that's a new line character, or if we maybe hit the end of the file, because maybe we're reading from a file. Actually, might hit the end of the file if it's like the last line. And so to do that, I'm going to do a while statement. So what goes inside this while? So I remember I can actually do some stuff in here where I can execute a statement in my test. So I'm going to do that inside these inner parentheses, and I'm going to read a single character. I'm going to do that by doing ch equals fgetC from input. And so the fact that I've wrapped it inside these parentheses means that it's going to read one character from input using fgetC. It's going to store it in ch, and at the same time it's also going to return, because in the parentheses, it's going to return the value of what's in ch. So I can actually test against that. So I want to actually put now another parentheses out here, and then if that is not a new line, and ch, because now I've to the left I've already assigned a value to ch, and as long as ch is not equal to the end of file, then it's going to do this loop. And so I think I've tried to be careful with my parentheses. This is one area where you can definitely mess up a program. So if you try to compile this program and you get a warning or an error that something's not right check your while statement, because you may have messed up with some of these parentheses. So we're going to go ahead and put characters into the string. So we're going to go ahead and put the character into the string. And so the string at position of n chars is going to be equal to the character that we just read. Now, as we are reading, what if that position we just stored it at is actually the last position in the array? It's as big as the array is currently. So we need to test if we need to make the string bigger. So do we need to make the string bigger? And then we're going to test by saying if the n chars is equal to the string size, stir size, then let's just, as a debugging statement, just in case I get this wrong, so fprintf to standard error, I'll just print out the message, realloc. No, I'm not putting in a new line there. It'll just insert itself into whatever it is I'm doing. And again, that's a debugging statement, so I can remove that one later. Now I need to do realloc. So to do that, I'm going to go ahead and figure out how big the new size needs to be. So it's going to be the current size plus get long stir size increment. And now that I figured out how big it's going to be, now I can use realloc. I'm going to store that into new stir. Realloc, remember, is going to return void star, so I need the right cast for that. So it's going to be char star. And so there's realloc. And remember, I need to tell it what to reallocate, and that's going to be stir. And now how big does it need to be? It's going to be new size, the number of characters that should be in there, times the size of each thing that's in there. And so that should give me a pointer to different memory. If it didn't work, I should test for that. So if new stir got returned as a null, then we had an error in allocating. So we should probably just return what we have. So we'll go ahead and assign our values back. Here we're doing a little bit of pointer assignment. So string, if you remember, that was the very, very, very top. That's the value that got passed to us, the string originally. So far we've been working with a local allocation. And string equals the local. And then string size equals stir size. And then I'm going to go ahead and return the number of characters I've been reading so far. And so that's just testing if it worked or not. And then I can go ahead and if it did work, I can now just reallocate, stir equals the new stir. And stir size equals the new size, right? That was just a temporary set of variables I was playing with to make sure that that I had something to test from realloc. And there's my other if statement. And then as long as I'm part of the while, before I leave that and go to my next entry in the loop to read the next character, I should increment nchars. Nchars equals nchars plus 1. And that's my while loop. Let's remind ourselves that's our while loop. And when I'm done, I'm gonna be nice to myself. I'm gonna actually insert a new line. So stir of nchars. So it's gonna exit this while when I hit return or when I hit the end of the file. So I'm gonna store at the end of it a null terminator. And then from that, my function is done. So I'm going to do string equals stir and string size equals stir size. And I'm going to return the number of characters that I've read. So before I write my main function that's going to actually use that, let's remind ourselves what this does. So I've been passing in the location of the current string, the location of the variable for string size, and a pointer to a file that I'm going to read. I set up my variables at the beginning. The most important thing here is that I've initialized nchars to 0. And now I'm going to just check if I need to allocate memory for the string. And if I do, I go ahead and do that here. And if it failed, it's going to return a negative number. Otherwise, it's going to go ahead and assign these variables. And that means that the string was already allocated before the function got called. But at this point, at the end of this if-else block, I'm using stir and stir size until I need to return the data. Now we're going to go ahead and use this big while loop that's going to read one character at a time. And as long as we haven't read a new line, and as long as we haven't read an EOF, an end of file, it's going to continue doing this loop. And so it's going to add a character to the string, and then it's going to increment the number of characters that it's read. And then in the middle, it's going to check if we need to make the string bigger. And that's what that's going to do. It's going to just, have I hit the size of my string? Have I read as many characters in as I need? Yes, then so I can go ahead and make the string bigger. And that's what I've done with realloc. And then I assign a null on the end of my string, and then I return. So let's go ahead and write a main function that tests this. So I'm going to do just an int main. I'm not going to pull anything with the command line, so I'll just do an empty argument list. And what am I going to put in that? Well, I'm going to start with my string, char string. I'm going to initialize that one to null because I'm not going to, I'll let the function allocate it for me. That also means I probably should make sure that the size is also set to 0. And then I need a place to hang on to how many characters were read, and chars. And now I'm going to go ahead and read a long line. So let's go ahead and put a prompt out there first. So put s, enter a really long string, and then go ahead and call getLongStir. So nchars is the we're just going to return the number of characters that it read. So I'm going to save that somewhere, and then getLongStir is the name of the function, and then the address to the string, and the address to size, and then standard in. And remember, I did this test. If it failed at the beginning, then it returned an error of nchars being a negative number. So if nchars is less than 0, then I probably just do an fprintf of an error. Oops, a standard error. Error calling getLongStir. Probably should free the string, be a nice programmer, and free the string because the function may have tried to allocate it, and then go ahead and return a negative or a non-zero return code to the operating system. Otherwise, it actually read the string, so let's go ahead and print the string. So let's go ahead and print some information about it. I could just do a printf. The string is, and then inside these brackets, I could do my my string. But let's also print some information about it. So I'm going to say printf. We read that many characters. So that was our nchars, and we the string is of size that size, and that should be it. And then once I'm done, go ahead and free the string because the function was allocating and reallocating as it went, and now I can return back to the operating system. Now let's test if I did that right. Save and quit. I16 GCC, turn on all warnings to make sure I didn't do anything wrong. We're going to output that as longstir.exe, and we're going to compile the source code file of longstir.c. Let's see if I made any errors. There's a lot of typing there. No warnings or errors coming back, so that's a good sign. So let's go ahead and run longstir. So there's my debugging statement, the malloc. That's the debugging statement. So I could just say hello. And so remember, it started by allocating 100 characters for the array. It read 5, HELLO. That's 5 characters long, and the string that it allocated is 100, and the string that it read was hello. And if I ran that again, longstir, I could put in something really, really, really long. So ASDF, we'll just do a bunch of Fs. That should be over 100. All right, it read 127 characters, but the string size is 200. And so that's why you can, it actually had to go back and do a realloc. You can see that it did the realloc. There's my output. That's a really convenient way to use realloc to change the size of an array and read something bigger. Now, reading a long string like that, that's something that a lot of people need to do. And so eventually there was a function added to C that allows you to read a long string. I think it was added in C99. I take it back. It was added in 2010. And that function is getLine. And it's not actually in the i16 version of GCC. But I will make sure there's a copy that is available for you on the programming guide. You can also find it online. I've got a copy that I've made here. So, oops, copy. And I think it's just getline.c. We'll call it getline.c. There we go. So here I've got a function that I've already pulled from, I think this is from BSD, that is getline.c, and it basically does the same thing. There's getLine is actually calling getDelim, and that will read a string up to some delimiter. In this case, it's going to read up to the new line, and it's very similar to what we just wrote. So let's go ahead and write a test program that uses that. So we'll do a program that we'll just call we'll call it line. Now here I need to do include standard.io.h. I need to include standardlib.h because the function is going to allocate the string, but I'll need to free it. So free is in the get standard lib. And I need to know how to call the function. You could write a header file for this, but for right now, I'll just go ahead and enter it in. The primitive for it is s, two s's on size t on get line. And it's char on a buffer and size t on a buffer size. So this looks very similar to what we wrote. And then a file pointer. And so that's the function primitive for getLine. Let's go ahead and write our simple main function. So int main. I'm not going to use any command line arguments, so I have an empty arg list here. We need to have a place to store our string, so char string, we'll set that to null to begin with, and size t, string size, we'll set that one to 0. Similar to what we did in our getLongStir function, and then size t, n chars, right? That's how many characters it actually read. So let's go ahead and just prompt ourselves. So we'll go ahead and read a long string, and we'll just do a prompt, put s, enter a really long string. Oops. And then just like we did before, n chars equals getLine. Oops. And we're going to do the address of the string. I'm going to do the address of the string size, and then we're going to be reading from standard in. Did we have an error? So how do we check for an error? Same as I did in the getLongStir. We're going to do if n chars is less than 1, then or I suppose 0, but I guess I already typed 1, so we'll just do fprintf standard error. I say error on getLine. And it may have actually tried to allocate some memory, so we'll go ahead and free string. Return back the operating system with a non-zero code. Oops. And if it did read the string, I'll go ahead and print the string. So printf, it read a certain number of characters. Now before I knew I was doing an int. In this case it's size t, and that's going to be the same as an unsigned integer, which is %u. And there's my new line, and there's n chars. Printf, the string is size, again, it's a size t, so that's %u for an unsigned long integer. And string size. And now we'll go ahead and print the string. So printf the string is, and then inside these brackets, I'll put my string. And then string. And now I'm done. So before I exit, I should be a good programmer and free the string and return 0. Let's go ahead and try that. Save and quit. Before I do that, let's go ahead and compile getline.c. So I can do I16 GCC, return on all warnings. I don't need to actually compile an executable yet, so we'll do -c. That'll just say just compile it without actually creating an executable. And I'm going to save it as getline.obj. That's the object file. Typically GCC though would use like a .o, but this is a file extension. It's more or less meaningless. So we can do .obj. You might see that on other C compilers. And I'm going to compile the getline.c. And if there aren't any warnings or errors in there, then I'll just get that. And you'll notice that I now have a getline.obj. No executable in that one. But I want to compile my program that I wrote in line.c. So I'm going to do an I16 GCC, turning on all warnings. I'm going to save the executable as line.exe. And I'm going to compile the line.c. And I've already compiled to an object getline.obj. And I'll hit return. And if I don't have any errors or warnings, oops, I do have an error there. It was supposed to be nchars, not chars. So we're going to do fed on line.c. And there it is. If nchars is less than 1. So I'll go ahead and save and quit. And we're going to recompile. And now if I don't have any errors or warnings, which I don't, now I can run line. So enter a really long string. Again, I can just type in hello. Interesting thing happens on this one is this actually includes that new line character. And so that's why that bracket is on the other line. It's because it actually is including the new line character. So you'll need to deal with that as you are reading lines using getline. I can also make a much longer string, but you'll see that the string has been allocated to a really long size anyway of 1024. So you know, I can make a really long string that's certainly over 100. And you know, the string itself has already been allocated at 1024. So that's pretty long. That's a lot of characters for me to type, and I won't do that here. So I'll go ahead and pause. This is enough for this week. Next week I'll cover some more advanced topics on C programming. Before I go, I just wanted to thank everybody who supports me on Patreon. You really do make this channel happen. Some of you are supporting me at a higher level, and I want to recognize you here, so thank you very much for that. And that's it for this week. So visit our website at freedos.org, join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.